Alright, so we're going to start by starting ROS core in one terminal window, switch over to the second, and we're going to start by running our test cases. A couple OpenCV windows will come up, just hit spacebar to close them. As the tests run right now, we wait for it. Come up, 14 tests to run total, all of them passed successfully. And then use our ROS launch file. We're going to navigate over a little bit so we can see the Turtlebot in our world. The world's made up of this one road using the road settings in Gazebo and blocks around the edges to create walls. You can see in the bottom left-hand screen right now is the lane detection algorithm. The two red lines are the edges of the lines. The green line is the center of the lane, and the blue line is the robot's current heading. It uses proportional control to keep it centered on the green line. And as you can see, there's some weird disturbances that kind of appear randomly. We're not 100% sure what causes those, but the controller does a relatively good job of rejecting them. Here you can see the stop sign was picked up and stopped. There's little things. One bug that we found is when there is that weird disturbance and the stop sign at the same time, the software will pick up the stop sign multiple times and cause it to stop like it is currently. Now that we're past the stop sign, it's relatively smooth sailing for a little bit. So we'll go over to ArViz, subscribe to the map. Show what that's looking at right now. And it's a bit jumpy, so we're going to try to limit the amount of time we spend looking at the map. Back over in Gazebo, we'll watch the robot take the first half of the turn. So when the vision algorithm loses one of the lanes, it turns until it sees it again. So there you can see it's going to turn to the left as it notices the lane, and then it reverts back to proportional control. Here's our map, mapping the turn. Back to Gazebo as we approach the second stop sign, and this one hopefully there won't be the disturbance, so we will have a better view of how the sign detection function works. So you can see the stop sign has been picked up, but it's still too far away, so the controller doesn't stop yet. Gotten close enough so the controller stops, and after it stops for a couple seconds it continues on, and it doesn't stop again for that stop sign. I'll continue on along the track until we complete our full loop. Back over into ArViz, you can see what is our map right now. There's one bug we've run into with Gmapping where you can see kind of, although the track itself, the two lanes are parallel, in the map it is going kind of branching out apart. We think this is an issue with the odometer. If you tell it through a Telop keyboard, the Turtlebot, just to drive straight, it tends to drive off to the right, kind of how the map looks like it's doing, and we think this is the cause for this kind of behavior in the mapping program. As it comes around the corner again, see it catches that corner of the map. Back to the gazebo, we can see where it's actually at. It should be meeting up with the other side, but there is that discrepancy of where the odometer is telling the map it's actually at. We had run tests in the past where the Gmapping software is able to bridge this gap, but it's a little bit of hit or miss, and in this instance it doesn't appear to be able to do it. Alright, so since it doesn't look like the maps are going to join up, we'll save it using the map saver function, and we can go look at what we saved. Right there.